Welcome to our exciting tutorial on data analysis with Apache Spark. In today's video, we'll dive deep into the powerful capabilities of Apache Spark for handling big data. Whether you're just starting out in data analysis or looking to enhance your skills, this video will cover all the essential aspects of Apache Spark that you need to know. Let's begin by understanding what Apache Spark is. Spark is an open-source, distributed computing system that provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. It can handle big data processing and analysis efficiently, making it widely used in the industry. Before we jump into the coding part, ensure you have the necessary tools installed. You'll need Java, Scala, or Python, and Apache Spark itself. You can download Spark from the official website. We'll also use Jupyter Notebook for our examples, as it provides an interactive environment for coding and visualization. Let's start by setting up our Spark environment. To do this, we will set up PySpark for Python users. First, make sure you have Python installed, along with pip. You can install PySpark by running the following command in your terminal. Now, let's create a basic Spark session to get started. The Spark session is the entry point for working with data frames and executing Spark operations. Here's how to create a Spark session in Python. Fantastic! Now that our Spark session is created, let's load some data. For this tutorial, we'll be using a sample dataset that contains information about flights. You can download it from the link in the description. Let's take a peek at the data we've loaded. One of the quickest ways to do this is by using the show method, which will display the first few rows of our data frame. As you can see, we have various columns in our dataset, including origin, destination, and date. Now let's perform some basic data analysis. First, we'll check for the number of records in our data frame by using the count function. Next, let's examine the schema of our data frame. The schema gives us an overview of the data types of each column, which can be quite helpful when analyzing our data. Now that we have a good understanding of our data, let's look for any missing values. We can accomplish this by using the isNull function in combination with filter to display records that have null values in specific columns. Next, let's aggregate our data to gain insights. For instance, we can group by the origin airport and calculate the average delay of flights from each airport. However, our resulting data frame might not be in the exact format we want. To rename the columns for better clarity, we can use the withColumnRenamed method. Visualization is a critical step in data analysis. To visualize our aggregated data, we can use libraries like Matplotlib and Seaborn along with PySpark. First, let's convert our data frame to a pandas data frame, which makes it easier to plot. Now let's create a bar chart to visualize the average delay from each airport. Here's how we can do this. Another crucial aspect of data analysis is to identify trends or patterns over time. Let's group our data by date and calculate the average delay each day. This will help us understand if there are specific days when flights tend to be delayed more. We can again visualize this aggregated data in a similar manner to our previous example. Let's convert it to a pandas data frame and plot the results. Now let's explore some more advanced analytical capabilities of Spark. We can utilize Spark SQL to run SQL queries on our data frame. First, we'll need to register our data frame as a temporary view. Once the data frame is registered, we can execute SQL queries just like we would in a typical SQL environment. For example, let's select the origin and destination airports along with the count of flights. You can see how easy it is to perform complex queries and data analysis with Spark SQL. And it's not limited to just counting. You can perform various aggregations and analyses, just like in traditional databases. To deepen our understanding of the data, it's often useful to join different data sets. For example, let's assume we had another data set of airport information that includes latitude and longitude. We can join these data sets to enrich our analysis. After joining the data sets, you can perform further analysis or visualizations. For instance, we could calculate the average delay from each airport while visualizing it on a map if we had geographic data. Finally, once you've completed your analysis, you might want to save your results. Spark makes it easy to write data frames back to various formats. For instance, to write it back as a CSV file. And there you have it. We have covered the essential steps in data analysis using Apache Spark, from setting up your environment to performing aggregations, visualizations, SQL operations, and saving your results. If you found this tutorial helpful, please like, share, and subscribe to our channel for more programming tutorials. Don't forget to comment below with your questions or suggestions for future videos. Happy coding!